Welcome to a lesson on the Cartesian plane. In this lesson, we'll be discussing ordered pairs and plotting points. We now begin looking at the relationships between two variables. Typically, one variable is considered to be the input, and the other is called the output. The input is the value that is considered first, and the output is the value corresponding to or is matched with the input. The input-output designation may represent a cause-effect relationship, but that is not always the case. But because of this, we sometimes say that the input controls the output or that the output depends on the input. Whenever we have values that represent the input-output relationship, we can organize them in what's called an ordered pair, where for an ordered pair we have the input value, comma, the corresponding output value in a set of parentheses, or in short, it's the input, comma, the output in parentheses. However, I do want to mention a common variable for the input is x, and a common variable for the output is y. So sometimes we see an ordered pair written as x comma y, but the variables don't have to be x and y, so we're going to refer to an ordered pair as the input comma the output. Example 1, we're asked to complete the table. So here we have an input of 4, an output of -3, and asked to write the ordered pair. So the input is first, comma, the output is second, and we organize this in a set of parentheses. Next, the input is 5 and the output is 8, so we have 5 comma 8 in parentheses. Next, we're given the ordered pair of 0 comma -4 and asked to give the input and the output. So the input is the first value or first coordinate, and the output is the second value or second coordinate of -4. Next, we have the ordered pair -2 comma 6, so the input is -2 and the output is 6. Now let's talk about the rectangular coordinate system, also known as the Cartesian coordinate system. It's formed by the intersection of two number lines, where we have a horizontal number line called the horizontal axis, or sometimes the x-axis, and a vertical number line called the vertical axis, or sometimes called the y-axis. We always find the input values along the horizontal axis, and we always find the output values along the vertical axis. The intersection point of these two axes, this point here, is called the origin. The origin has the ordered pair or coordinates 0, 0. So at this point or this location, the input is 0 and the output is 0. We can use this coordinate system to represent the relationship between two variables graphically. For example, every ordered pair here would be a unique point or location on this coordinate system. Let's go ahead and graph these four ordered pairs by plotting them as points on the coordinate system. So the first ordered pair is 4 comma -3, so we have an input of 4 and an output of -3. So because the input is 4 from the origin, we would go right 4 units. Remember, the input is always along the horizontal axis, and then because the output is -3, which we find along the vertical axis, from here we would go down 3 units. This would be the location of the point with coordinates or the ordered pair 4 comma -3. Notice at this location we have an input of 4 and an output of -3. Next we have the ordered pair 5 comma 8, so because the input is 5 from the origin we would go right 5 units, and then because the output is +8 we would go up 8 units. This would be the location of the point with coordinates or ordered pair 5 comma 8. Notice at this location we have an input of 5 and an output of 8. Next we have the ordered pair 0 comma -4, so now the input is 0 and the output is -4. So because the input is 0 from the origin, we don't move left or right, but because the output is -4, we would go down 4 units. The location of the point with coordinates or ordered pair 0 comma -4 would be here, right on the vertical axis. And then finally we have the ordered pair -2 comma 6. So the input is -2 and the output is 6. So because the input is -2 from the origin, we would go left 2 units. And because the output is +6, we would go up 6 units from here. This would be the location of the point with coordinates or ordered pair -2, 6. Notice at this location the input is -2 and the output is +6. I hope you found this helpful. Welcome back to part 2 of the introduction to the Cartesian coordinate plane. In this part, we'll plot additional points as well as define the 4 quadrants. We want to begin by plotting the points given here on the right on the rectangular coordinate system. Remember, every point has an ordered pair where the first value or first coordinate is the input and the second value or second coordinate is the output. And we always find the inputs along the horizontal axis, and we always find the outputs along the vertical axis. So notice that point A has the ordered pair -4, 2, so we have an input of -4 and an output of +2. So to find the location of this point from the origin, because the output is -4, we would go left 4 units to -4 on the horizontal axis, and then because the output is +2, we would go up 2 units to the output of +2. This is a location of point A. Notice how at this location we have an input of -4 and an output of +2. Point B has the ordered pair 3, 8, so the input is 3 and the output is 8. So because the input is 3 from the origin, we would move right 3 units to +3 on the horizontal axis, and then because the output is +8, from here we would go up 8 units to the output of +8. This is the location of point B. At this location we have an input of 3 and an output of 8. For point C we have the ordered pair 0, -5, so the input is 0 and the output is -5. So from the origin, because the input is 0, we don't move left to right, we stay here where the input is 0, but because the output is -5, from here we do go down 5 units to the output of -5. This would be the location of point C. At this location we have an input of 0 and an output of -5. For point D we have the ordered pair -6, -4. We have an input of -6, an output of -4. So because the input is -6 from the origin, we would move left 6 units to -6 on the horizontal axis. And because the output is -4, from here we go down 4 units to the output of -4. This is a location of point D. Once again, notice how we have an input of -6 and an output of -4. For point E, we have the ordered pair 5, 0. So we have an input of 5 and output of 0. So because the input is +5 from the origin, we would move right 5 units to an input of +5. From here, because the output is 0, we don't move left or right. Point E is here on the horizontal axis. At this location, we have an input of 5 and an output of 0. Point F, we have the ordered pair 2, -8. So we have an input of +2 and output of -8. So because the input is +2 from the origin, we move right 2 units to the input of +2. Because the output is -8, we move down 8 units to an output of -8. This would be the location of point F. Once again, notice point F has an input of 2 and an output of -8. And then finally we have point G with the ordered pair 0, 0. Remember, the ordered pair 0, 0 is the origin, this point here, the intersection of the two number lines. Notice here both the input and the output are 0. Now let's talk about the 4 quadrants. Notice how the two number lines divide the coordinate plane into 4 different regions or 4 different quadrants. This quadrant here in the upper right hand corner, this is where both the input and the output are positive. And then from here we go counterclockwise. The second quadrant is this quadrant here. This quadrant is when the input is negative and the output is positive. This quadrant here is the third quadrant. This is where the input is negative and the output is negative. And finally, we have the fourth quadrant here. Notice how we're using Roman numerals to indicate the quadrant. And quadrant 4 is where the input is positive and the output is negative. Let's look at some examples. Let's say this point here that has the ordered pair 2, 4, notice is in the first quadrant because both the input and output are positive. This point here would have the ordered pair -7, 3. This is in the second quadrant because the input is negative and the output is positive. This point here would have coordinates or have the ordered pair -4, -3. Both the input and output are negative, so we're in the third quadrant. And here, let's say, this point has coordinates or ordered pair 7, -2. This point is in the fourth quadrant because the input is positive and the output is negative. Now you might be asking, what happens if we have a point that's on one of the axes? Let's say we have a point here with coordinates 0, 8, which is on the vertical axis. We typically say this point would not be in one of the quadrants, it's actually on one of the axes or on one of the borders of the quadrants. The same thing for a point, let's say here, on the horizontal axis. This point would have coordinates -5, 0. We would say it's not in one of the quadrants, it's on the horizontal axis. Okay, I hope you found this helpful. Welcome to part 1 of our lesson on graphing equations by plotting points. In example 1, we want to use the equation y equals 1/2 x minus 2 to complete the table below and then graph the results. So looking at the table, notice how we're given the input values or x values. We want to find the corresponding output values or y values, then write the ordered pairs, and then plot the points on the coordinate plane. Before we find the output values, notice how all the input values are multiples of 2. The reason for this is, if we look at our equation, notice y is equal to 1/2 x minus 2. So because of this product here where we have 1/2 times x, if we want this product to be an integer value, we want the input values or x values to be multiples of the denominator. Notice how our denominator is 2 and the inputs are multiples of 2. If we had 1/3 times x, we would want the input values to be multiples of 3. If we had 1/4 x, we'd want the input values to be multiples of 4, and so on. So looking at this first row, we have an input or x value of -6, which means y would be equal to 1/2 times -6. And because we have a fraction here, I'm going to write -6 as -6/1, and then minus 2. Now we want to find this product. Notice there's a common factor of 2 between 2 and 6. There's 1, 2, and 2, and 3 2's and 6. So we have y equals, this is now just 1 times -3, which is -3. Then we have minus 2. So the corresponding output value, or y value, is -5. So when the input is -6, the output is -5, which means the ordered pair is -6, -5. Now going back to this product just for a moment, remember we can view 1/2 times -6 as half a copy of -6, which is equal to -3. So we can also think of these products in that way. The next input value is -4, so we'd have y, the output, is equal to 1/2 times -4, or -4/1, minus 2. Again, we have a common factor of 2 here. There's 1, 2, and 2, and 2 2's and 4. So we have y equals 1 times -2, which is -2, minus 2. So we have y equals -4. So when the input is -4, the output is also -4. So the ordered pair is -4, -4. Then again, we could have also thought of this product here as half a copy of -4, which is -2. The next input is -2, so we have y equals 1/2 times -2, or -2/1, minus 2. So we have y equals 1/2 times -2 means half a copy of -2, which is -1. Or simplifying, we have a common factor of 2 between 2 and 2. There's 1, 2, and 2, and 1, 2, and 2 here. So we have 1 times -1, which is -1, minus 2. So we have y equals -3. So when the input is -2, the output is -3. So the ordered pair is -2, -3. The next input value, or x value, is 0.
So we'd have y equals 1/2 times 0 minus 2. So y is equal to 0 minus 2, or -2. So when the input is 0, the output is -2. The ordered pair is 0, -2. The next input is 2, so we have y equals 1/2 times 2, or 2 over 1, minus 2. Well, 1/2 times 2 we should recognize would be equal to 1 because these are reciprocals. So we have y equals 1 minus 2, so y equals -1. So when the input is 2, the output is -1. We have the ordered pair 2, comma, -1. The next input is 4, so we have y equals 1/2 times 4, or 4 over 1, minus 2. 1/2 times 4 means half a copy of 4, which is 2. We're showing the simplification. There's 1, 2, and 2, and 2 2's and 4. So we have y equals 1 times 2 is 2, minus 2, so we have y equals 0. So the ordered pair is 4, comma, 0. And the last input is 6. So the output is going to be y equals 1/2 times 6, or 6 over 1, minus 2. 1/2 times 6 means half a copy of 6, which is 3. We're showing the work there's 1, 2, and 2, and 3 2's and 6. So we have y equals 1 times 3 is 3, minus 2. Y is equal to 1. So when the input is 6, the output is 1. So the ordered pair is 6, comma, 1. Now let's go ahead and plot these points on the coordinate plane. So we'll first sketch the horizontal and vertical axes. So here's the horizontal axis for the inputs, and here's the vertical axis for the outputs. Notice how the inputs go from -6 to +6, and the outputs go from -5 to +1, which means we'll be fine if we scale the axes by ones. So on the horizontal axis to the right of the origin, we'd have 1, 2, 3, and so on. And to the left of the origin, we'd have -1, -2, -3, and so on. On the vertical axis up from the origin, we'd have 1, 2, 3, and so on. And below the origin, on the vertical axis, we'd have -1, -2, -3, and so on. And now let's plot the points given by the ordered pairs. The first ordered pair is -6, comma, -5. So because the input is -6, we'll move to -6 on the horizontal axis. And then because the output is -5, we'll move down 5 units to here, where the output is -5. So the input is -6, and the output is -5, and that's why this is the point with the ordered pair -6, comma, -5. The next ordered pair is -4, comma, -4. So we first go to -4 on the horizontal axis, which would be here. So the input is -4, and the output is -4. So from here we'll go down 4 units to here, where the output is -4. So this ordered pair is -4, comma, -4. The next ordered pair is -2, comma, -3. So because the input is -2, we start here on the horizontal axis, and because the output is -3, we move down 3 units to here, where the output is -3. The next ordered pair is 0, comma, -2. So because the input is 0, we're going to be right here at the origin, where this is 0 on the horizontal axis. And then because the output is -2, move down 2 units to here, where the output is -2. This is the ordered pair 0, comma, -2. Remember, whenever the input value is 0, the point will always be on the vertical axis. The next ordered pair is 2, comma, -1. So we'll start at 2 on the horizontal axis, where the input is 2. Because the output is -1, we'll move down 1 unit here, where the output is -1. The next ordered pair is 4, comma, 0. So we begin by going to 4 on the horizontal axis here, where the input is 4. And because the output is 0, we don't move up or down. The ordered pair 4, comma, 0 would be this point here on the horizontal axis. Remember, any point where the output is 0 will always be on the horizontal axis. And then finally we have the ordered pair 6, comma, 1. So we move to 6 on the horizontal axis, where the input is 6. And because the output is 1, move up 1 unit to here, where the output is +1. So now we have all the points given by the ordered pairs plotted on the Cartesian plane or coordinate plane. Now, because our equation is telling us y, the output, is equal to 1/2 times x, the input, minus 2 for any input x, we want to go ahead and sketch the graph of the line passing through all of these points. So this would be the graph of the equation y equals 1/2 x minus 2. Any point on this line would satisfy the given equation. Now before we go, let's take a look at this on the graphing calculator. To check our table is correct, we can enter the equation y equals 1/2 x minus 2 into the calculator by pressing y equals. And then because we already have y1 equals, we'll just enter 1/2 x minus 2. So 1 divided by 2 is how we enter 1/2. And then here's the x key, and then minus 2. Now before we go to the table by pressing second graph, let's go to the table set by pressing second window. Notice how right now the table is going to start at 0, it's going to change by ones, and it's on automatic, so we can scroll up or down in the table. So if we press second graph, we can scroll up to -6 and verify the output of -5 is correct. And now scrolling down, here's the ordered pair -4, -4. Here's the ordered pair -2, -3, followed by the ordered pair 0, -2, and so on. Now to verify our graph, let's adjust the window or the scale on the axes to match our axes. So we'll press window, and we'll change the x min and x max to, let's say, from -7, enter, to +7, enter. The scale is by ones, and now we'll do the same for the y min and y max. So we'll go down to y min, enter -7, enter, 7, enter. And now if we press graph, the graph should match our graph, which we did by hand, and notice how it does. I hope you found this helpful.
To determine the midpoint of a segment, we first need to find the coordinates of the endpoints of the segment, and then we find the average of the x-coordinates, and we find the average of the y-coordinates. These values will give us the coordinates of the midpoint. Looking at our segment here, graphed on the coordinate plane, this endpoint has an x-coordinate of -2 and a y-coordinate of 5. And this endpoint has an x-coordinate of +3 and a y-coordinate of -2. And now if we call this x sub 1 and this y sub 1 and this x sub 2 and this y sub 2, the x-coordinate of the midpoint will be -2 plus 3 divided by 2, and the y-coordinate will be 5 plus -2 divided by 2. Well, -2 plus 3 is equal to 1, so we'd have 1/2 for the x-coordinate of the midpoint, and 5 plus -2 is equal to 3, so the y-coordinate of the midpoint would be 3/2. Of course, it might be helpful to write these as decimals if we were going to plot the point by hand. And since 1/2 is equal to 0.5, and 3/2 is equal to 1.5, we could also express the midpoint in decimal form. So if we wanted to plot this point, we'd move to the right of the origin half a unit and up 1.5 units to this point right here. This would be our midpoint. Which means if this is segment AB with midpoint M, we can say that segment AM is congruent to segment MB. Which means segment AM is the same length as segment MB, which we can show using these hash marks. And I also graphed the segment and midpoint using graphing software. I hope you found this helpful. Welcome to a lesson on how to determine the distance between 2 points. The distance between 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, is given as d, the distance, is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Now, even though this formula looks quite different from the Pythagorean theorem, it is a result of the Pythagorean theorem. So I'd like to take a moment and show where this formula comes from. We know if we have a right triangle that c squared is equal to a squared plus b squared, where c would be the length of the hypotenuse and a and b would be the lengths of the two legs. So this would be c. Let's go ahead and call this leg A and this leg B. If we wanted to determine the length of hypotenuse C, we could solve this equation for C by taking the square root of both sides. So we would have C would equal the square root of A squared plus B squared. And remember that A is just the length of this leg here, and B is the length of this leg here. Now if this right triangle was on the coordinate plane, we could call the coordinates of this point x1, y1, and we could call this point here x2, y2. Well, notice that the length of this side A would just be, notice the length of this side A would be determined by the distance between x sub 1 and x sub 2. So A would be equal to x sub 2 minus x sub 1. And the length of B would be determined by the y-coordinates of these 2 points, which would be the difference between y sub 2 and y sub 1. So B would be equal to y sub 2 minus y sub 1. So the only difference between the Pythagorean theorem as we see here solve for C and the distance formula is we're substituting x sub 2 minus x sub 1 for A, and we're substituting y sub 2 minus y sub 1 for B. So if we perform these substitutions, we'll have the exact distance formula we just showed on the previous screen. So let's go ahead and do it. Instead of C, we'll use D for distance. So now we'll replace A with x2 minus x1 squared plus, now we'll replace B with y2 minus y1. And we have the exact distance formula as we saw on the previous screen. Now let's go ahead and do an example. We want to determine the distance between the points -2, 9 and 3, 4. The first thing I like to do is label the coordinates of these points. I'm going to call this x sub 1 and this y sub 1. And I'll call this x sub 2 and I'll call this y sub 2. It doesn't matter whether we label these the 1s or the 2s, but if we call this x sub 1, we do have to call this y sub 1. We can't interchange the 1s and the 2s within a given point. Okay, so our distance should be equal to the square root of x2 minus x1. That'll be 3 minus -2 squared plus y2 minus y1. That'll be 4 minus 9 squared. And now we need to simplify this. Well, 3 minus -2 will become 3 plus 2, so this will be 5 squared, plus 4 minus 9 is -5, so we'll have -5 squared. Well, 5 squared is 25, and -5 squared is also 25, so our distance is equal to the square root of 50. Now at this point, it really depends on what class you're taking. If we just want a decimal approximation, we can go ahead and type this into the calculator in this form. Let's go ahead and do that. We're going to type in the square root of 50. And let's go ahead and round to 2 decimal places. So we'll say it's approximately 7.07 units. However, if your instructor wants you to write this in simplified radical form, remember you can rewrite 50 as 25 times 2. Well, the square root of 25 would be 5, so the simplified radical form for the square root of 50 would be 5 square root 2. And again, it just depends on what class you're taking and in what form they want the answer. This is simplified radical form, and this is the decimal approximation. Let's go and take a look at this graphically. Again, we said this distance here was approximately equal to 7.07. Notice the horizontal distance here from -2 to +3 would be 5 units. The vertical distance here from 4 to 9 would also be 5 units. Now just to do a quick comparison, if we wanted to label this side C for the hypotenuse and use the Pythagorean theorem, we should obviously come up with the same answer. We would have C squared equals, let's call this A, so we'd have 5 squared plus B squared, which would be 5 squared again. So we have C squared equals 25 plus 25, which is 50. And so we have the hypotenuse would have a length of square root 50, which we just showed on the previous screen was approximately 7.07. Okay, I hope you found this video helpful. Thank you for watching.